In the darkness, where light loses its meaning and space bends as if it is not sure of its boundaries, there is an object that for a long time remained only a quiet hint of the impossible. It does not flash like a star and does not go out like the usual cosmic lights. It does not emit signals that can be easily deciphered. It simply exists, and by doing so, it disrupts the usual order of the universe. Cygnus X-1 is a region where matter ceases to behave like matter in the usual sense. Here, the gas, accelerated to monstrous speeds, is swirled into a bright disk which emits powerful X-rays before disappearing into the invisible center. The center itself does not reflect light, does not return signals, and does not leave direct traces of its presence. It cannot be seen, but it can be detected by the way the space around it behaves.
In this system, there is a massive blue supergiant whose surface is constantly losing matter. Streams of plasma break away from it and rush towards the invisible partner. This is not a collision in the usual sense, but a continuous fall of matter into a region where speed, energy, and gravity reach the limits known to the physics of the observable world. As this substance approaches the brink of extinction, it heats up to millions of degrees. At this moment, the cosmos literally begins to glow in a range inaccessible to human vision. X-ray telescopes record these bursts as signals from an area where familiar laws cease to provide an intuitive explanation for what is happening.
Cygnus X-1 has long been the subject of controversy. The invisible center of the system did not allow direct confirmation of its nature, but the behavior of the surrounding matter gradually ruled out all other options. No ordinary star could hold such a powerful gravitational influence without emitting its own light. No known object is able to cause matter to disappear without a trace, leaving only the radiation energy at the boundary of the fall. Over time, it became clear that there was a region where the mass was so compressed that the space around it was bent to the limit. Light that passes too close loses the ability to go back. It is captured not by an object in the usual sense, but by the geometry of space itself. But even this does not explain the full depth of what is happening. Inside the accretion disk rotating around the center, matter moves at almost the speed of light. Particle collisions generate bursts of energy that sometimes exceed the total radiation of entire star systems. And all this happens on the border of the invisible horizon, a conditional line beyond which information ceases to return back to the observable universe. Cygnus X-1 does not exist in isolation. It is part of a complex binary system where the life of one star is gradually redistributed in favor of another object. This is not destruction in the usual sense, but a slow process of cosmic exchange, where matter becomes energy and energy becomes radiation, before disappearing beyond the observable.
And the longer the observation continues, the clearer it becomes. Such objects are not uncommon anomalies. They are the natural result of the evolution of massive stars that have reached the end of their life cycles. When the fuel inside the core is exhausted, gravity no longer meets resistance. At this point, collapse begins, leading to the formation of an area where space ceases to be just a background for events and becomes an active participant in them. Cygnus X-1 was the first confirmed example of such a process. He opened a window into a region of the universe where observation requires not sight, but analysis of consequences. It is not the shapes that are important here, but the trajectories. Not light, but its absence. Not the object, but the influence it leaves on the surrounding cosmos.
And in this silence of the gravitational limit lies one of the deepest truths of the cosmos. That which cannot be seen directly is sometimes much more powerful than anything that shines in the night sky. The formation of such an object begins long before it becomes the dark center of the system. This is the final stage of a massive star's life, where the balance between internal pressure and gravity can no longer be maintained. A nucleus that has exhausted thermonuclear fuel loses its ability to withstand its own weight. A rapid contraction of matter begins, in which the density increases to limits not found in ordinary stellar conditions.
The outer layers of the star react to this in different ways. Some of the matter is ejected into space in the form of powerful streams. Some remains bound by gravity and begins to fall inside. It is at this stage that the basis of a future system with a black hole and an accretion disk is formed. If there is a massive companion nearby, the process becomes even more dynamic. Gravitational interaction begins to pull matter from one star to another, creating a continuous flow of matter. In the case of Cygnus X-1, this system has acquired a stable structure in which a massive star loses matter and a compact object captures it. But the capture does not happen instantly. The substance does not fall directly into the center. It has angular momentum, and this causes it to move in a spiral, gradually approaching the region of maximum gravitational influence.
This is how an accretion disk is formed, a rotating structure of heated gas and plasma. At high speeds, the particles collide with each other, lose energy, and gradually move to lower orbits. Each such transition is accompanied by the release of energy, which goes away in the form of radiation. That is why accretion disks become one of the brightest sources of X-rays in the observable universe. The temperature in these structures reaches millions of degrees. Matter no longer exists in the familiar form of atoms. Electrons separate from the nuclei, forming a plasma in which particles move under the influence of not only gravity, but also electromagnetic fields resulting from chaotic collisions and the rotation of the disk.
As you approach the center, the speed of rotation increases. The inner layers of the accretion disk move closer and closer to the speed of light. This is where the effects associated with general relativity begin to appear. Time flows differently for matter closer to the center than for the outer regions of the disk. This is not an abstract phenomenon, but a physical reality that affects the dynamics of the entire structure. The innermost stable orbital radius becomes the boundary beyond which orbital movement is no longer possible. The substance loses stability and begins to fall rapidly inside. This region plays a key role in shaping the observed characteristics of the system, as it is where the maximum conversion of gravitational energy into radiation takes place.
Then begins the area where the usual trajectories cease to exist. Space and time are curved so much that all paths lead in only one direction, inward. This is the zone approaching the event horizon. The event horizon is not a physical surface. This is a boundary determined not by matter, but by the ability of information to leave the gravitational field. When this boundary is crossed, no signal, including light, is able to return to the outside. The laws of causality are preserved, but their manifestation becomes one-sided.
Matter approaching this region experiences extreme acceleration. The gravitational gradient becomes so strong that different parts of the same flow feel different attractions. This results in a stretching effect, in which the structure of matter is stretched along the direction of the fall. However, In the vicinity of massive stellar mass black holes like Cygnus X-1, this process occurs beyond the horizon, where it is still possible to observe the consequences. Part of the matter does not have time to cross the border and becomes a source of intense radiation. It is this region that forms the last bright signal before matter disappears from the observable universe. The energy released here is the converted gravitational energy of falling, one of the most efficient forms of energy transformation in space.
Relativistic jets are of particular importance in such systems. They do not always form, but when the magnetic fields of the accretion disk line up in a certain way, some of the falling matter is not directed inward, but is ejected along the axis of rotation of the system. These jets consist of plasma accelerated to speeds close to the speed of light. Relativistic jets are able to extend over huge distances, going far beyond the system itself. They carry with them energy and particles that interact with the interstellar medium, creating shock waves and regions of gas heating. Despite the fact that Cygnus X-1 is not the most powerful source of such jets, the very mechanism of their formation remains universal for such objects.
Closer to the event horizon, the accretion disk becomes less and less stable. The flows of matter lose order. The structure breaks up into turbulent zones, where the movement is determined not by orbital dynamics, but by extreme gradients of the gravitational field. Here, each fragment of matter follows its own trajectory, completely subordinated to the curvature of space. And in this transition layer, there is a final separation between what can still be observed and what already goes beyond any information. All the energy, all the structure, all the interaction of matter and field is concentrated at the extinction boundary, where the universe continues to record the consequences, but no longer receives an answer from within.
There are no trajectories beyond the event horizon in the usual sense. The very possibility of movement outward disappears there. Any vector, any direction, any attempt to describe the path of matter comes down to one result: a fall into a region where space and time change roles. For falling matter, the process of crossing this boundary is not accompanied by an external impact or a wall. At the local level, everything can look continuous. The accretion flow continues to move, the structure of matter persists long enough that there is no abrupt break in its own physical interactions. But the global picture of space has already irreversibly changed. All possible future states are directed inward.
Near this boundary, one of the strangest effects of strong gravity is a slowing down of time relative to external observation. The closer the flow of matter is to the event horizon, the more its evolution is stretched in the coordinates of outer spacetime. From the point of view of distant regions, matter seems to freeze at the boundary, gradually dimming due to the loss of radiation energy. However, for the substance itself, time continues to pass, and the transition within occurs without stopping. Cygnus X-1 demonstrates this through the behavior of the internal accretion flow. Radiation emanating from a region close to the horizon bears traces of extreme gravitational redshift. Photons lose energy, stretch in wavelength, and go to softer ranges of the spectrum. Part of the information about the structure of the falling matter is literally dissolved in the altered spectrum of radiation.
But even deeper begins the realm where even the concept of orbit ceases to exist. It is not a surface or a layer, but a dynamic zone in which the geometry of space is so curved that all possible paths are closed inward. Here, the light cones tilt so much that all directions of the future are directed toward the center. This is the fundamental reason for the impossibility of information coming out from within. The internal flow of matter becomes more and more unstable. The magnetic fields that previously held the structure of the accretion disk are beginning to lose their organization. Turbulence increases, and local clumps of plasma are formed, which live for a short time before being absorbed further. In this chaos, the usual hierarchy of structure disappears. There are no stable orbits, no permanent layers. There is only a continuous fall and redistribution of energy.
At the same time, the black hole itself does not consume matter in the classical sense. It does not accumulate matter as an object that expands. Its mass increases, but this increase manifests itself exclusively through a change in the geometry of the space around it. The added energy and momentum change the curvature, making the gravitational field even deeper. Near objects such as Cygnus X-1, the boundary between stable and unstable orbits begins to play an important role. There are regions where particles can still exist on relatively stable trajectories, but the slightest disturbance puts them in a falling mode. This thin dynamic zone forms a transition between the bright accretion disk and the dark region, where light can no longer hold on. Relativistic effects in this zone become not just noticeable, but dominant. The geometry of space is so distorted that orbital motion acquires additional precessional components. Trajectories cease to be closed, even if the event horizon has not yet been formally crossed. This creates a complex structure of flows, where matter moves along constantly changing paths, gradually losing stability. And yet, it is in these conditions that the most powerful energy processes are born. The gravitational energy of the fall is converted into radiation with tremendous efficiency. Some of the material may be temporarily trapped near the inner radius, creating bursts of brightness observed as variable system activity. These bursts are a reflection of the struggle between the last stable configurations of matter and the inevitable inward direction.
Looking even further back in the system, it becomes clear that the Cygnus X-1 is not an isolated point of destruction, but an element of a larger dynamic. Interaction with a companion, flows of matter, changes in orbits, and redistribution of mass form the long-term evolution of the entire system. Over time, this connection can change both the donor star and the black hole itself, gradually shifting the balance of mass and orbital parameters. But within all these processes, one structure remains unchanged, a region where space is so curved that no information can leave it. It is this boundary that makes Cygnus X-1 not just a bright source of X-rays, but the physical limit of observability, where the universe continues to evolve, but without feedback from within.
Over time, the accretion disk around Cygnus X-1 ceases to be a static structure, even in a conventional sense. It exists as a continuous process, not as an object. At each moment, some of the material in it is formed anew due to the influx from the companion star, and some disappears, moving outside the observable region. This is not a cycle in the usual sense, but a constant flow of redistribution of matter and energy. The inner regions of the disk become increasingly sensitive to the slightest changes in the gravitational field. Any local increase in density leads to a restructuring of flows. Orbits shift, trajectories overlap, and zones with increased turbulence are formed. These zones are not stable. They exist only within short time intervals, after which they disintegrate under the influence of colossal gravitational gradients. Under such conditions, magnetic fields begin to play the role of not just a structure, but a mechanism for energy transfer. The magnetic field lines that permeate the disk plasma are twisted by rotation and break when critical stresses are reached. At the moment of rupture, there is a rapid release of energy, accompanied by the acceleration of particles. These processes form the basis of flare activity observed in the X-ray range. Closer to the inner radius of the accretion disk, a special region arises where the motion of matter can no longer be described as orbital. Here, the particles lose the ability to rotate steadily and begin to move in spirals with an ever-decreasing radius. This is not a smooth fall, but a series of transitions between increasingly unstable configurations, each of which exists only for a moment on the scale of the system. The energy released in this zone reaches extreme values. A significant part of the mass of matter is converted into radiation even before crossing the event horizon. That is why black holes with accretion disks are among the most efficient energy converters in the universe. Up to tens of percent of the mass of matter can be emitted in the form of photons and particles. Cygnus X-1 also demonstrates a complex interaction between the rotation of a black hole and the structure of the surrounding space. If a central object has rotation, it causes the space-time around it to become entangled. The geometry of space begins to twist, creating an effect in which even light trajectories acquire an additional displacement. This phenomenon increases the asymmetry of the accretion flow and affects the distribution of energy in the disk.
The outer layers of the system react to this through a change in the accretion regime. The flow of material from the companion star can be uneven, creating phases of increased activity and relative calm. During periods of increased inflow, the disk becomes brighter, denser, and more unstable, and X-rays increase. During periods of weakening flows, the system partially calms down, although internal processes continue without stopping. At the boundary of the inner region of the accretion disk, a transition layer is formed, where matter exists in a state of extreme instability. Here, particles are constantly transitioning between bound and unbound states, colliding, exchanging energy and angular momentum. This layer plays a key role in the formation of the system's radiation spectrum, since it is here that the bulk of high-energy photons are born.
Then begins a region where space no longer allows the existence of stable trajectories. All possible geodesic lines, the paths of least action, point inward. This is not a local effect, but a global property of the geometry near the event horizon. That is why no structure of matter can preserve itself unchanged when it crosses this boundary. But even before the event horizon is reached, the system is already showing signs of irreversibility. Streams of matter lose the memory of their original structure. Chemical composition, density inhomogeneities, and local ordered structures are all destroyed by turbulence, heating, and gravitational shear. Only a set of fundamental parameters remains: energy, momentum, and charge. It is these parameters that ultimately determine everything that remains of matter after crossing the horizon. From the perspective of outer space, the entire complex structure of matter disappears, leaving only a contribution to the black hole's mass, charge, and spin. The rest of the information becomes inaccessible to observation. Relativistic jets, if formed, become a separate channel for the redistribution of the system's energy. Part of the matter, not getting inside, accelerates along the axis of rotation and is ejected into interstellar space. These jets carry energy over vast distances, interacting with the environment and forming shock fronts.
They serve as a kind of output
for some of the energy that has not been absorbed by the event horizon. And as a result, the entire Cygnus X-1 system turns out to be not a completion point, but a node of constant exchange between a star and a compact object, between matter and radiation, between falling and ejection. Within this node, space continues to bend to the limit, and matter continues to follow the only possible direction, closer and closer to the boundary, where observation ceases, but the physical process continues.
If we delve even further into the behavior of the system, it becomes clear that the accretion around Cygnus X-1 is never completely symmetrical. Even with a steady influx of matter, the structure of the disk is constantly shifting. Dense regions arise, collapse, and form again, as if the geometry of the flow itself cannot hold its perfect shape. This instability is due to the fact that the matter in the disk lives in a regime of constant redistribution of energy and angular momentum. Each colliding fragment of plasma does not just lose speed, it transfers it to other layers, creating a chain reaction of changes. As a result, the inner regions of the disk become an arena of continuous dynamics where there is not a single steady state, only transitions between them. As you approach the center, these transitions accelerate. The time of the characteristic processes decreases, the energy density increases, and the length of the trajectories is reduced to the minimum allowed by the geometry of space. At some point, matter ceases to orbit in even an approximate sense. It no longer chooses a path. It follows the bending of space, which itself directs it towards the center. It is here that the boundary begins to appear, which is not a physical barrier, but determines the entire structure of the system's behavior. Space is so curved that all possible future directions for falling matter are oriented inward. Any attempt to change the trajectory requires energy that exceeds the available local margin of the system. In this region, the last layer of the radiating substance is formed, a thin but extremely energetic transition region. Here, photons are born in conditions where the gravitational field is already beginning to dominate all other interactions. Each photon, before leaving this zone, loses part of its energy, stretches, changes frequency, and goes into space in a distorted form, bearing an imprint of a deep gravitational well. The closer to the center, the stronger the effect of the difference between the local and remote picture of processes is manifested. For the matter inside the accretion flow, the dip remains a continuous and finite process. To the outside space, it looks more and more slowed down and blurred, until it turns into an almost motionless glow at the boundary. This is not an illusion, but a consequence of the curvature of time built into the very structure of space. Then begins the area where even the concept of state of matter loses its usual meaning. Plasma approaching the event horizon can no longer maintain stable configurations. Atomic structures have been destroyed long before, but now even plasma orderliness is disintegrating. Only the flow of elementary interactions remains, completely subordinate to the geometry of space-time. If we consider the system as a whole, it becomes clear that the accretion disk is not a surface, but a process. It does not have a fixed shape because its shape is determined by the balance between inflow, radiation, and fall. Any change in one of these factors instantly rebuilds the entire structure, but never brings about equilibrium. Equilibrium near such objects is impossible. The system exists only in dynamics. And in this dynamics, relativistic jets become a special mechanism for energy redistribution. They are formed when the magnetic fields and the rotation of the system are arranged in such a way that part of the matter receives acceleration along the axis of rotation. This acceleration is not limited by the accretion disk and is not directly related to the fall. It uses the energy of rotation and the magnetic structure. As a result, narrow but powerful plasma flows appear that go far beyond the system. These jets carry with them traces of the conditions in which they were born: high-energy particles, radiation, magnetic structure. But as they move away, they expand, lose density, and interact with the interstellar medium, creating extended regions of perturbation. Meanwhile, the inner part of the system continues its inevitable process. Material that has not been ejected gradually crosses an area where stable trajectories are no longer possible. Its further fate ceases to be part of the observed dynamics. It becomes part of the internal geometry of the black hole, inaccessible to external description. And it is at this point that the main limit of understanding such systems arises. All that can be observed is the boundary of processes. Everything that happens next remains hidden not because of a lack of technology, but because of the very structure of space, where information stops coming back.